Hey everyone, I'm Error. This is a tutorial for EO, the first step of the ZZ method. I'll first explain the concept behind EO, and then I'll show you how to solve the EO step. EO stands for edge orientation, which is the way that edges are twisted on the cube. Now, why does that matter? There are 6 basic moves on the cube, and we can split them into 2 groups. The first group is R, U, L, and D moves. And I'm going to call them natural moves because they're generally easier and more comfortable to do with your hands. However, F and B moves are unnatural moves because they're more awkward unless you're in specific hand positions. In a good finger trick friendly method, we want to use as many of these natural moves as possible and avoid the unnatural moves. That begs the question, can we solve the entire cube using only natural moves? The answer is almost. The closest that you can get is something like this, where some of the edges are flipped, and it turns out natural moves don't have the power to twist these edges. So these edges that are twisted wrong, these are called bad edges. They're twisted in a way such that you can't solve them with natural moves. But the rest are good edges. They're twisted in a way that you can solve them with natural moves. The idea of ZZ is to add an extra step at the beginning of the solve that twists all the bad edges into good edges, and then everything can be solved with natural moves. This step is the focus of the video. Here's an example of a good edge. So the way that this edge is twisted lets us solve it with natural moves. So U moves, R moves. Here it is. But if we go back and then we twisted it, now it's a bad edge because the way it's twisted prevents us from solving it with natural moves. So if we do the same thing as before, obviously it's twisted in its spot, but it turns out that no matter what you do with natural moves, you can never twist edges. To understand why natural moves can't twist edges, I'll first explain the concept of orbits. So when you turn the cube with R, U, L, and D moves, the ways the stickers move around the cube is limited. It turns out that there are 2 separate regions of edge stickers called orbits. The first orbit is the purple orbit, all the spots that I've marked in purple on this cube. So all the top spots, bottom, and then the front 2 and the back 2. Remember this. And then the second orbit is everything that is outside the purple orbit, which I'll just call the outer orbit. These are all the spots that I've marked with an X here. During natural moves, the sticker on one orbit will stay on that orbit. For example, this yellow sticker on this edge is currently on the purple orbit. This is its corresponding spot, and if you look at all the places that it can visit, if we just do natural moves, so everything here at the top, you do L moves, it goes all the way around like this, D moves all around the bottom, and then R like that. You do get every single spot I've marked purple here. And likewise, this blue sticker here will visit everything in the outer orbit. This means the way that the edges are twisted, or their orientation, will always stay the same when you do natural moves, making it impossible to flip edges. For example, if we wanted to flip this bad edge, then you can see that we want the yellow sticker, which is currently on the purple orbit, to switch with the blue sticker so that it is now outside of the purple orbit. But you can't do that with natural moves. So the only option is to use unnatural moves, which are the only moves capable of moving stickers in between orbits. For example, if you have the edge piece on the F layer, and then you do an F prime move, what happens is that this yellow sticker, which started out here, is now outside of the purple orbit. So the orientation of this edge has changed, and now it is a good edge, solvable with natural moves. What we just did there, turning a bad edge into a good edge with an unnatural move, is called orienting an edge. And the goal of the EO step is to orient all the edges on the cube, turning all the bad ones into good ones. But how can you tell which edges are bad on a cube? Now obviously this one is bad because natural moves can't flip edges, but what if it was somewhere else? How can you tell that that's a bad edge? In the next section, I'll give you a simple system to recognize these bad edges, then I'll show you how to orient them. Here's an example so you can follow along. Scramble with white top and green front. By the way, the orientation of the edges, whether they're good or bad, changes if you hold the cube at a different angle. So it's best to choose two centers to be your top and your front, and then keep it that way throughout the solve. Here I've chosen orange top, green front. Let's also give a name to all the sticker colors. For example, let's call this the R sticker because it matches the color of the R center, and then this is a U sticker because it matches the U center. To find bad edges, look for two things. The first is L and R stickers on the purple orbit. In our case, our L and R stickers are yellow and white. So we need to look for yellows and whites on the purple orbit. So we can see right away there's a white sticker here. So this edge is bad. Looking at the front, there's no yellows or whites. Looking at the bottom, we see a yellow here and a white there. So these two are bad edges. And then looking at the back, there's nothing. So we just found 3 bad edges, and I'm going to mark them with tape to keep track of them. Here's what we have so far. The second thing to look for is U and D stickers on the outer orbit. So on our cube, we're looking for orange and red stickers on the outer orbit. So we can start on the left side, and then we can see that there are no oranges and reds here. The front side, there's one here in these 2 spots. So I'll mark this as a bad edge. On the right side, we see that there are 2 oranges and reds. This we already know it's bad, and then this bad edge I'll mark. And at the back, we can see in these 2 spots, there is an orange here, so I'll mark that as bad. In total, we have 6 bad edges, and the number of bad edges will always be an even number from 0 to 12. But why do these rules work to identify bad edges? We said that it's a problem if L and R stickers are on the purple orbit, because these L and R stickers belong completely outside of the purple orbit, and there's no way that you can bring these stickers from the purple orbit outside of it using natural moves. So those edges are bad. And likewise, if you have U and D stickers on the outer orbit, that's a problem because those U and D stickers belong all on the purple orbit. So those edges are bad. Now I'll show you how to orient edges. The main strategy is to fix bad edges 4 at a time. So right now we have 6 bad edges, and I'll show you how to eliminate 4 of them right now. To do that, use natural moves to move 4 bad edges to the F layer. So we already have 2 on the F layer. Move a 3rd bad edge to the F layer with an L prime, and then the 4th one can go in with a U2. And now we have 4 bad edges on the F layer. And then do a single F or F prime to orient all these bad edges into good ones. So F. And now all of them are good. This works because 90-degree F moves flips the orientation of all 4 F layer edges. So if they are all bad, then they become all good. But this also means that doing F again flips them back to what they were. So F2 doesn't affect orientation. So in addition to natural moves, you can also use F2 to move pieces around if it's convenient without worrying about messing up edge orientation. So for example, in this case, it would be kind of tedious to only use natural moves. Like you would have to do something like this. But if you're allowed to use F moves, then you can do something much simpler. You can do F2 to create an opening to insert this in one go. And now you have all 4 bad edges on the front, and then you can do an F as usual. Everything I said about the F layer is also the same for the B layer. So if it's more convenient, you can also move your bad edges to the B layer and then do a B or B prime to orient them. B2 also doesn't affect edge orientation. If you repeat fixing 4 bad edges every time, you'll either orient them all, or in our case, you'll have 2 leftover edges left. To solve a 2 bad edges case, I'll show you how to turn it into a 4 bad edges case that can then be solved as usual. The way this works is similar to fixing 4 bad edges at once, but instead, you only want one single bad edge on the F or the B layers. And we already have one that's already there, make sure it's the only one. And then you can do a B or B prime in this case. So let's do a B, and what happens is this bad edge becomes a good edge, but now you have 3 new bad edges here. This works because if you have 1 bad, 3 good, that turns into 1 good, 3 bad, which effectively adds 2 more bad edges. So that's how you turn 2 bad edges into 4. Now we have 3 new bad edges here, and then 1 bad edge from before, so that makes a 4 bad edges case. We can solve this as usual by putting all bad edges on either the F or the B layer. So let's choose the B layer, and then we'll do a B, and then all of these become good edges. Now EO is solved, and now the cube is solvable with natural moves. You can continue with the rest of the ZZ method. Here are some tips to get you started with EO. For this video, I helped keep track of the bad edges by putting pieces of tape on them. But during your own solves, you can start by putting your fingers over where the bad edges are. And another way to keep track of bad edges is to draw visual shapes in your head. So this could be like a triangle. These 2 edges here could make a diagonal line, stuff like that. And to make tracking a lot easier if you have many bad edges, in particular if you have more bad than good, is to only keep track of the good edges. For example, in this 8 bad edges case, there will be 4 good edges that you can keep track of instead of the 8 bad. Here's a special trick for 6 and 10 bad edges cases that can make your solutions simpler. So normally I tell you to eliminate groups of 4 bad edges until no remain, or you have 2 leftover edges. Then you add 2 more bad edges and then eliminate these as usual. However, there's a simpler way, which is to directly remove 2 bad edges at the beginning, and then you can proceed as normal. The special trick goes like this. Put exactly 3 bad edges on either the F or B layers, and then do an F or B turn. So watch this. 3 bad edges, 1 good, becomes 3 good, 1 bad, effectively removing 2 bad edges. Note that this doesn't work for 2 bad edges cases because you need to have at least 3 bad edges in total to perform this trick. This is why it's useful for 6 and 10 bad edges cases. EO step at the beginning is kind of hard, but it gets much easier with practice. You'll be able to identify bad edges much quicker, find solutions much more easily, and be able to plan more of it during inspection. I've also made another example solve of the EO step linked in the description below if you need more examples. We learned exactly how ZZEO works with orbits and stuff, and then we learned how to recognize and solve bad edges. The next step for you is to do some more untimed EO solves so you can familiarize yourself with doing it, and then you can move on to EO cross, ZZF2L, and edges-oriented last layer. Thank you so much for watching, and there's more videos coming, so don't miss it. Stay subscribed.